4 physical changes of ethanol are listed. So condensation, conversion of gas to the liquid, and evaporation, conversion of liquid to the gas, and freezing, conversion of liquid to the solid, and boiling is a rapid conversion of liquid to the gas. So in which changes do the particle move further apart? So in which changes, the volume is increasing, so the particles are moving away from each other. So in that way, the statement number 2, the evaporation, and 4, boiling. So volume is increasing, so the particles are moving away. So that's why the correct statement is 2 and 4. C is our correct answer. In question number 2, an atom of element X contains 5 protons and 6 neutron and 5 electron. So atomic number is equal to 5, and nucleon number mean atomic mass is proton number plus neutron number is equal to 11, while electronic arrangement is first shell contain 2 electrons, and the second shell is remaining 3 electrons. So valence shell contains 3 electrons, so mean it belongs to the group 3 in periodic table. So which statement about the element X are correct? So X has an atomic number 6. So that's a wrong statement. Why? Because it has atomic number 5. X has a nucleon number 11. It's a correct statement. And X is in the group 2 of the periodic table. It's wrong. It belongs to the group 3 in the periodic table. So X is in the second period. It is a correct statement. Why? Because it contains 2 shells. So that's why the statement number 2 and 4 are correct. So D is our correct answer here. Ammonia is a covalent molecule, which diagram show the outer shell electron arrangement in the molecule of ammonia. So we can see that the nitrogen is present in the 5th group in the periodic table. So the outermost electron are 5. What about hydrogen is in the 1st group in the periodic table. So the outermost electron number is 1. So that's why we can see that the nitrogen in A is wrong. Why? Because the nitrogen is representing the cross electron. Cross is the representation of electron placed in an outermost shell of nitrogen. So these are 3. 2 are missing. So that's why it is the wrong statement. So here, that's the B is here the nitrogen contains outermost the 3 electrons, so that's a wrong representation. The 2 electron in nitrogen are missing. What about 1 extra electron is given in the hydrogen? So that's a wrong. What about C is a correct statement. You can see the nitrogen, the outermost electron are 5, are represented by cross, while hydrogen is 1 is represented by 1 dot. So in that way, this is a correct diagram. What about the D is also wrong. Why? You can see the hydrogen is having extra electron. So that's why this extra electron, that's a wrong statement. So in that way, the C is our correct answer. Question number 4, which structure does the silicon oxide most closely resemble? So it is most closely resembled to the diamond. Why? Because both are organic molecule, and in both each atom is bonded with other 4 atoms and making tetrahedral arrangement. So that's why this is similar to the diamond. What about the carbon dioxide and sodium chloride are inorganic molecule, so their arrangement is different. What about graphite? Each atom is linking to 3 other atoms, and there's no tetrahedral arrangement. There is a layer structure, so that's why more resemblance to the diamond. So B will be our correct answer here. Question number 5, the substance P conduct electricity when solid. Which particles move in a solid P so that it can conduct electricity? So if anything is in a solid state, only electron can move in a solid state. So anion or cations cannot move in a solid state. So that's why the D is our correct answer here. Which equations represent a chemical change? So in a chemical change, the bond breaking and making is involved, and there's a new substance is formed during a chemical change. So we can see the barium chloride is converting into a barium chloride from solid to the liquid state. This is a physical change. There's no new substances being formed. What about calcium ion react with the sulfate and they're producing calcium sulfate. So a new substance is being formed. So that these chemical in reactant converting from ionic state to they are coming in a compound state, and they're coming and they're producing solidified new substances being formed. So that's why the B is our correct option here. What about the potassium chloride is dissolving into the water and convert into its ionic state, and that's dissociate potassium ion and chlorine. So this is a kind of physical chain of a dissolution and no new substances being formed. So, and the D is the sodium and nitrate. So they are dissolving in a liquid and stay in an ionic state. So until they are placed in aqueous solutions, so they are in an ionic state. So there's no new substances being formed. So B is our correct answer here. Which sample contain largest number of molecule? So here you need to calculate the number of the molecule by multiplying the moles of the given substance. So for finding the number of the molecule, first you need to find the mole. So there is a formula. The number of mole is equal to the mass, which is given there, divided by the molar mass of the substance. What about the number of molecule? So number of mole multiplied to the Avogadro number. If you multiply, so you'll get exact number of molecules. So here in option A, so 16 gram of methane is a given there. So we need to convert first from 16 gram of methane to its mole. So its molar mass is 16 gram. So what about the carbon is 12 plus 4 hydrogen. So each hydrogen contains 1. You can get from periodic table their value. So that will be 16 grams. So 16 over 16, that's 1 mole. 1 is going to multiply with the Avogadro number, 6.022 in 10 raised to power 23. So answers are same. So these are number of particle. In the same way, we're going to get that the number of particle of 16 gram of oxygen. So 16 divided by 32 molar mass. So this will give us 0.5 moles, which will multiply with the Avogadro number, and we'll get 3.011. So this is, as compared to the A, it's a half number. So you can see in a C option, the 16 gram of phosphorus, and that's the one phosphorus contain 31 in periodic table. These are relative atomic mass. So 31 multiplied 4, this is 124 gram is a molecular mass. So 16 gram divided by 124, this will give us 0.129 moles. If you multiply with the Avogadro number, so our answer is 7.77 into 10 raised to the power 22. So in the same way, we have a 16 dm cube of a methane at the standard temperature and pressure. So that way, at the standard temperature pressure, every mole contains 24 dm cube. So if there's a 24 dm cube, so there's a 24 dm cube is given there. So you can place here. That's R3 is in the number. I'm trying to draw that. So this is our 24 dm cube. So in this way, 16 divided by 24 dm cube. So we will get our answer 0.67 moles. So in that way, that's our, if you multiply to the Avogadro number, so this given number is there. So here you need to compare about number of molecule. So highest number of the molecules are present in 16 gram of methane. So you can go also a more simplified state. I just did a complete calculation for you for your understanding. But in the questions, in the question paper, there will be less time. So you can quickly do your rough work and proceed to the answer. So the question number 8 is our titration process. The concentration of a sample dilute aqueous sodium hydroxide is found by titrations. So apparatus used in shown there, and in this way we have an burette hydrochloric acid. While in conical flask we are having sodium hydroxide as a base. So concentration of the hydrochloric acid we are representing with a C1, and the volume of hydrochloric acid by V1, and concentration of the sodium hydroxide is C2, and volume of sodium hydroxide is C. This is going to be our value V2. So we are representing this value is our V2. Okay, so here we have here the formula is C1V1 is equal to the C2V2. So we need to calculate the volume of the sodium hydroxide. So in this way, the C1V1 divided by V2. So we need the concentration of a hydrochloric acid, volume of hydrochloric acid, and the concentration of the sodium hydroxide is needed for this formula to calculate. So if you're going to see that, so we can have. So we need for this calculation, which information is needed to calculate the concentration of dilute aqueous sodium hydroxide. So if you want to calculate the dilute aqueous sodium hydroxide concentration, so according to the given formula, we need the concentration of hydrochloric acid. So it's correct. Volume of hydrochloric acid, it's correct. We don't need the molar mass of hydrochloric acid. We need only the volume of sodium hydroxide, and we don't need a molar mass of sodium hydroxide. So in that way, the B will be our correct answer here. So we can proceed to the question number 9. In an experiment number 1, the aqueous copper sulfate is electrolyzed using graphite electrode. So, and in experiment number 2, the aqueous copper sulfate is electrolyzed by using copper electrode. So, which statement is identify the half equations of the one of the electrode? So you can see if you are performing the aqueous copper sulfate electrolysis, so at anode, what will happen? So the copper will oxidize, that will release the electron, and this will convert into +2 oxidation state. What about oxygen that contain a negative charge? This will proceed to the anode, and that will oxidize to the oxygen gas. So this will release in the form of bubbles of oxygen gas at anode. What about the cathode? What is happening? So these positively charged copper ions, they will proceed to the cathode, and they will reduce at cathode and deposit at cathode in atomic state here. So now that's copper will release at cathode. So that's overall concept. We're going to see that which statement is correct. So in an experiment number 1, the half equations for anode reaction is 4 hydroxyl ions. They will proceed and they're going to produce 2 water molecule. Oxygen is released and 4 electrons are releasing here. So that is the correct half equation. So what is releasing at anode? In an experiment number 1, and the half equations of cathode reaction is the hydrogen. So now here, the hydrogen is wrong. Hydrogen gas will not release. The reason is what? So the copper is below the hydrogen in electrochemical series. So that way, the hydrogen is more reactive while the copper is less reactive. So in that way, the copper can reduce easily as compared to the hydrogen. So that's why we are expecting here. So the copper will release a cathode as compared to the hydrogen. So that is a wrong statement. See, in an experiment number 2, the half equations are for anode reactions. So we studied about like the copper is reducing at cathode, not at anode. In the same way, in an experiment number 2, so the half equations for cathode for hydroxyl. So hydroxyl group will proceed to the anode, not on cathode. So that's why the correct statement is A here. Which substance is not produced during the electrolysis of the concentrated aqueous sodium chloride? So if you're performing the electrolysis, so in that way, the most important word for you that what is the concentration of the sodium chloride? Because we are having in a molten state of sodium chloride, and we have dilute sodium chloride, and we have a concentrated sodium chloride. So in this way, the product will be different at cathode and anode. So you need to be more focused on this word, concentrated. So according to the concentrated statement, we can see at anode, so chlorine that will release the electron, and this will convert into a gaseous state. So at at anode, the chlorine is releasing in the form of the bubble that will be green color, and in this way at cathode, the hydrogen that will reduce to the hydrogen gas. What about in electrolytic solutions? So there's a sodium is from the salt. What about hydroxyl is coming from water? They may react with each other in producing sodium hydroxide. So question is, now which statement is not produced? So in that way, the chlorine is being produced, hydrogen is being produced, and the sodium hydroxide is being produced. So in that way, the sodium will not produce. So in the next year, examiner can design this type of a questions like, is this process is possible to extract the pure sodium by electrolysis by using the concentrated aqueous sodium chloride? So the option will be not. Why? Because we cannot extract the pure sodium by this process. So that way, the option is C here. Methane burn in excess of oxygen, and the equation is given there. Methane react with oxygen and produce carbon dioxide and water. So the bond energy, the total energy placed in the bond, that is called a bond energy. So we need to calculate here the correct bond energy. So the bond energy are shown there in the table. So carbon and oxygen, that's a double bond is 805. Carbon and hydrogen, that's 410. And oxygen is 496. And oxygen and hydrogen is 460. These are given there. Now here we have a concept here. So energy absorbs in breaking the bond. So in a reactant side, while the energy releases in a making the bond in product side. So we need to see that in a reactant side, in the methane, there is a 4 carbon and hydrogen bond. So 4 multiply 410. Plus in oxygen, there are 2 oxygen molecules. So in this way, 2 multiply 496. So that will give us a total value 2,632. What about in product side, the carbon dioxide that contain 2 bonds of oxygen and carbon. So that will 2 multiply 805. And in the same way, the 2 water molecule, and each water molecule contain oxygen and hydrogen 2 bond. So in that way, that will be total 4. So 4 multiply 460, answer is 3,450, and this is our energy release. So that way we are representing in minus. So we're going to subtract this energy, reactant minus the product energy. So answer is coming in minus. So that's why it is an exothermic reaction. Now, this information is not directly related to the question, but that type of question might be possible in next year. So we're going to proceed to the question here. What is the energy change for this reaction? So you can see that our calculation is correct according to the option A. What about in option B? He split it, reactant to the product and product to the reactant. So that's why it is a wrong statement. And C and D are calculating the wrongly. So that's why our A is our correct option here. Question number 12, which changes increase the rate of reaction by decreasing the reactive activation energy? So here, that's a role of enzyme or role of catalyst is to lower the activation energy. So if there's an inorganic catalyst or organic catalyst, their function is to decrease the activation energy. So activation energy, we define a minimum energy is required to convert reactant into the product. And in this way, the catalyst is decreasing activation energy, so easily reactant convert into the product and rate of reaction increases. So A is our correct answer. What about the B? So decreasing in a size. So this decreasing in a size will increase the surface area. So that's why more rate of reaction will increase by increasing surface area, not by lowering activation energy. And in the C option, so increase in reaction rate by more collagens. If you're increasing the concentration, so the number of collagen will increase. In the same way, if you're increasing the temperature, so the kinetic energy will increase, the number of the collagen will increase. So A is our correct option here. In question number 13, in the contact process, the sulfur dioxide react with oxygen to form sulfur trioxide. So which conditions are used in these reactions? So that's a knowledge-based question. There are two processes are included, Haber process and contact process. So you need to learn by heart what conditions are essential to keep these reactions forward in directions, because these are reversible reactions. So this way, we need the lowering of temperature, that is 450 degrees Celsius, and the pressure is needed, high pressure 200 kilopascal pressure, and the catalyst is needed vanadium oxide. That's a knowledge-based question. You need to learn behind these are the conditions for this contact process and Haber process. So C is our correct option here. Which reaction is reversible in nature? So we can see an iron nail is rusting with when left in the moist air. So this iron react with oxygen, and that produce iron oxide. That's a stable molecule. That's our stable compound it will produce. So in this way, this is not reversible. In the limestone, that's reacting with acid to produce the carbon dioxide, and that produce carbon oxide. So, that produced the calcium oxide. Now, this calcium oxide is a stable molecule. It's not a reversible. In the same way, the magnesium is a burn in the presence of air, and that produces magnesium oxide. It's a stable molecule. What about we have a white anhydrous copper sulfate? Anhydrous means there's a deficiency of water. There's no water in that. And if we are turning, so if we ate the water molecule in that, and this will turn blue color. So, and that's a reversible process. Why? Because if you heat it, water will evaporate, and once again, this will turn into white color, and that will become anhydrous. So by adding, this will become hydrated. By removing water, that will become anhydrous. So this is a reversible process, and it also used to detect the water molecule as well. So in that way, this is our reversible chemical change. D is our correct answer here. The question number 15, the equations for the reaction of sulfur dioxide with acidified potassium dichromate is shown there. So here, that's the sulfur dioxide is reacting with there is a potassium dichromate, chromate ion are given there, and they are converting into the sulfate ion and chromate ion, and water molecule is being produced. What is oxidized and what is oxidizing agent? So the oxidized, you can see, if you see that the sulfur dioxide is converting into a sulfur tetraoxide in a product. So in an oxidation state, in a reactant, you can see the sulfur is +4 oxidation state and oxygen is -4 oxidation state. So that's a stable, that's why there is no charge on that. So what about in product, the sulfur, the oxygen are 4 multiplied 2 each oxygen. So that is -8 oxidation state in oxygen. What about the sulfur is +6 oxidation state? Why? Because maximum electron of sulfur can share an outermost shell, that's the 6. So in that way, that is in +6 oxidation state. So in that way, what is happening? The oxidation state is increasing of a sulfur, and in this way, the sulfur is oxidized. Sulfur dioxide is oxidized from reactant to the product. What about this oxygen is coming from chromate? So that's why the chromate is reduced, and it is an oxidizing agent. So that's why the chromate is oxidizing the sulfur dioxide and the adding oxygen and sulfur dioxide. So that's why the chromate is an oxidizing agent. What about the sulfur dioxide is reduced by, it's reduced. Sorry, that's the sulfur dioxide is oxidized. What about chromate is reduced itself and work as an oxidizing agent for sulfur dioxide. So here, correct option is A here. What is the definition of strong acid? So when we define the strong acid, the proton donor that is completely dissociate in an aqueous solution. So that's why here acceptor is a wrong word here. So a proton acceptor, once again, is a wrong word. So correct statement, a proton donor that is completely dissociate in aqueous solution. So that's a correct statement. So what about the proton donor that is partially dissociate? This is weak acid. So C is our correct option. Which statement about the amphoteric oxide is correct? So here we have 3 different types of oxide. When the metal is reacting with oxygen and producing oxide, so that is our basic oxide. For example, calcium oxide. In the same way, the non-metal, they are reacting with the oxygen and producing acidic oxide. For example, the carbon dioxide, when it will dissolve in the water and produce carbonic acid. And in the same way, we have when there are certain type of the metal which react with the oxygen and it produce certain type of oxide, for example, aluminum oxide and zinc oxide. So these oxides behave both acid and base. So that's why these are called amphoteric oxide. So C is our correct option. They react both with acid and base. So here, A is the A is the wrong option. They are made by combining acetic oxide. They're not made by combining acetic oxide. They're directly metal react with oxygen and produce the oxides. And in the same way, their pH value will be either above the pH 7 or either below the pH 7. Why? Because they're behaving the acidic and basic both. And they do not react. They can react both with the acid and base. So C is our correct option here. The copper carbonate is formed when aqueous sodium carbonate is added to an aqueous copper nitrate. So ionic equations for this reaction is given there. For example, the carbonate ion, and they're reacting with the copper and produce the copper carbonate. That's in solidified state. So new substance is being formed. So in this way, you can see that's a salt. Copper carbonate is an insoluble salt. So how is a pure copper carbonate is obtained from the reaction mixture? So first, we filter it to separate it from the solvent. Why? Because it is insoluble. In a second step, we wash it to remove extra impurities. And in the third step, we dry it to get the pure crystal of the copper carbonate. So that's a correct way of getting the pure form of the copper carbonate. So D is our correct option here. Question number 19. So Q and R are elements in the same period of the periodic table. So they're present in the same period in the periodic table. Now Q has a 7 electron in an outermost shell, and R has a 2 electron in outermost shell. So on the basis of this information, we can see that the Q is a 7 electron, so it means it is in 7 group in the periodic table. These are non-metals. What about the R is in the second group in the periodic table? This is metal. So which statement about the Q and R are correct here? So Q is a metal and R is a non-metal. These are opposite statement are given there. So that's why this is wrong option. Now, Q and R have a different number of electrons here. So this information, I mean, the number of the proton or electron numbers is not given there. So their outermost shell is given there. So that's why it is a wrong statement. So R is not found, or R is found to the right of the Q in the periodic table. So you can see that R is present in the second group. So that's why it is present to the left side of the 7 group. So that's why the R is a metal. So that's the most probably that's present to the left side. So of the periodic table. So the D is the proton number of R is less than the proton number of Q. So we see that if you're proceeding from left to right in a periodic table, the atomic number is increasing. So in this way, the number of the proton are increasing. So R in the group 2, while in the Q is in the group 7. So and the number of the proton in R is less as compared to the Q. So D is our correct statement here. Question number 20, the lead sulfate is an insoluble salt. So which reaction produces a mixture from which the lead sulfate is obtained by filtrations? So that's a knowledge-based question. So lead sulfate is an insoluble salt. And in this way, you need a reactant for that. So we have a lead nitrate, so that contains a lead. And we have the sulfuric acid, and this contains a sulfate. So we are adding together in an aqueous form. And this is producing insoluble lead sulfate. And that's producing the nitric acid, so that's in aqueous form. So we filter it and we can separate from the solvent and the lead sulfate. So it's in a solidified state as in a residue. So that's the reactant you need to learn by heart. So that's included in our syllabus. So lead nitrate and sulfuric acid is needed to produce lead sulfate salt. So here D is our correct answer here. Which statement about alkali metal is correct? So alkali metal, that belongs to the group 1 in the periodic table. So that's include lithium, sodium, potassium, and rubidium, and cesium, and francium. So here, to know the answer for this question, we should know that the property of the group 1, that's training property in periodic table. So that means the density increases down the group, and reactivity increases down the group in periodic table. What about the melting point? So this melting point is decreasing down the group. So A option, the lithium is more dense than sodium. So we can see that the density is increasing down the group. So lithium is supposed to be less than sodium. Why? Because the lithium is coming before the sodium. So that's why it's the wrong statement. Sodium is more reactive. So sodium is supposed to be less reactive according to trend. And the C is the correct statement. The sodium has a higher melting point than potassium. So in this way, you can see that the melting point is decreasing down the group, and sodium is coming first. So that's why it has a higher melting point as compared to the potassium. And they are in the group 2. That is wrong. This is alkali metal, so they are present in the group 1. So C is our correct statement here. Which row describes the property of transition element? So transition element, due to the presence of unpaired electron, have a stronger bonding. And due to this, the stronger bonding, they're having high melting point and they have a high density. And second, they have the electrons, transition electron in a d orbital. So due to the presence of electron in the d orbital, and in this way, they change the colors, and they're having the colorful compound. So according to this given information of transition element, so they have a high melting point, they have a high density, and they form the colored compound. Yes, so B is our correct statement here. So this B is a correct option. Which row identifies the property of zinc? So here, about the zinc, all metals are good conductor of heat and electricity. Zinc is included in metals, so it also has this property. And second, we have aluminum, zinc, iron, and magnesium. They can react with a dilute acid. So when they react with the dilute acid, so they are producing their respective product. So here, so a thermal conductivity, they are good conductor of heat and electricity. So that's why, because it's metal, and this react with dilute acid. So any one of them that can react with the dilute acid. So yes, so A is our correct option here. Uses of metal depend on their properties. Which property is necessary for the use given here? For example, the use of metal is a car body. If you're using for the car body, it's supposed to be malleable, mean converted to the sheet, thin sheet, or it's supposed to be hard. It's supposed to be resistant to the corrosion. So what about here? It's a ductile, convert into a wire. So that's why it is not suitable. So it's a wrong option. Cutlery, for that we need it's supposed to be malleable, it's supposed to be high density or shiny in a structure. What about here? That's a given conduct heat, so that's not needed for cutlery. What about in a D option, overhead wire? So for that wire, it's supposed to be ductile in nature. So the property of metal, they are converted into the wire form. So that's why the high density is not required for them. So C is our correct option. So food container, so they are resistant to corrosions. So we are using that type of the metal which has resistance to the corrosions. So they are used in a food container. So C is our correct option here. Question number 25, which compound both contribute to acid rain? So what is acid rain? Whenever the oxide of sulfur react with the water vapors in air and they produce the sulfuric acid in clouds. In the same way, the oxide of nitrogen, they react with the water molecule and they produce nitric acid. So these acidic clouds are considered acid rain. Why? Because whatever the rain produced in the result of precipitation of these clouds, that will have a low pH value. And it's dangerous for our plant, dangerous for aquatic life. So what is the correct option here? So you can see in the C, the oxide of nitrogen and sulfur dioxide, so they are making the acid rain. So C is our correct option here. Question number 26. So PQ, RS are metal. So P react with the dilute hydrochloric acid and forming the hydrogen. So these are certain metals. For example, aluminum, zinc, iron, and magnesium. They can react with the dilute hydrochloric acid and release hydrogen gas. Now Q react violently with water. So it's a high reactivity. So it means it's present in the group 1 in periodic table. So violently mean it is, that's our, most probably it is going to be, is our, the potassium metal. So it's violently reacting. So second is R, that react with water to give hydrogen. So it's present in the group 1 because they can directly react with the water and release the hydrogen. So, but less reactive than Q. In the same way, acids are formed by heating its oxide with carbon. So zinc is zinc oxide, and this is zinc is oxide is reduced to metallic zinc by heating with the carbon. It has the particular property for zinc. So which row identify the metals? So here you can see in a column number 1, the P. So number 1, so P is, that's react with the dilute hydrochloric acid. So that's include, for example, copper is not included. So we can exclude copper from here. So the remaining option are B, C, and D. So we're going to proceed to the Q option here. So in a Q column, so it react violently with water. So in that way, the sodium and the potassium, they can react with the water with the water. So that's why magnesium we are excluding here. So we can see the most possible option are C and D. Now in the column 3, so you can see that react with the water to give a hydrogen. So it means this is a less reactive than to the Q. So if you can see that in a group 1 in a periodic table, so R is coming to the sodium and the Q is the potassium. So why? Because this is going to be, this is R is, the Q is a potassium here, the R is the sodium. So in that way, how we got idea? So because it is a less reactive, so here there's a two words are being used, only react and violently react with the water. So this way, here that the property means R is a less reactive than to the water. So that's why this is coming. The R is going to be a sodium. So in the third option, the calcium will cancel here. So you're not supposed to proceed to the column number 4. So whenever this type of the complicated questions are coming, so in this way, if you're following this strategy to falsification, like after column number 1, you're supposed to focus on three option only, B, C, and D. After column number 3, you're supposed to focus on C and D. And in this way, if you are comparing this property and if you can see like reactivity increases down the group, so that's why the Q is more reactive as compared to the R. So in this way, that's our more reactant violently, so that will be our potassium. So in that way, you can easily get your answer more quickly. So that's the correct answer will be D here. What about in the last? The zinc is has a particular property. It can form an oxide with carbon. Which compound is formed when iron rust? So rusting of iron involved, for example, when the iron is reacting with the oxygen, and that iron is reacting with the water molecule, so that is the water is aided with the iron oxides, and in this way that is producing hydrates of iron oxide. So this is a rusting condition. So we can say hydrated iron oxide. So if the water molecule is aided with the iron oxide, so that is a hydrated iron oxide. D is our correct option here. What about anhydrous mean without water? Anhydrous mean without water. What about hydrated iron hydroxide is a wrong option here. That is iron oxide. So D is our correct option here. Why is the cryolite used in extraction of aluminium by electrolysis? So we can see that the cryolite is act as a solvent and it helped to lower the melting point of aluminium oxide. The alumina mean aluminium oxide. And second, when it's in the molten stage, it can conduct electricity. So that's why the extractions of aluminium is easy from its ore. So the correct option is it dissolves the aluminium oxide. Why? Because cryolites work as a solvent for aluminium oxide. So second, it protects the anode and from the corrosion. That's the wrong option. It is not its property. It changes the bauxite to aluminium oxide. Now, aluminium oxide with other raw material, it's also called a bauxite. So that's a non-logical statement. It's already in the bauxite state. Second, it decreases the melting point of aluminium. Now, word aluminium is wrong. Aluminium is in a pure state. What about alumina or aluminium oxide is a raw material. So that's why it is decreasing the melting point of a raw material, not the pure aluminium. So A is our correct option here. A wax candle is made from the mixture of carbohydrate. So these are hydrocarbon, meaning which consists of the carbon and hydrogen only. So the candle is light and the place in the gas jar along with the strip of cobalt chloride test paper as shown there. So you can see what is the function of the cobalt chloride is to detect the moisture from the water, and it's changing the color from blue to pink. So this is the indicator for moisture or the water. What about when the candle wax will burn and this will produce hydrocarbon will burn in the presence of oxygen, and that produce the carbon dioxide and water molecules. So these hydrocarbons are producing the product, the carbon dioxide and water molecule. So in that way, after a short time, the oxygen in the jar is used up and the candle, the flame goes out. So which substance does the cobalt chloride, the paper is identified. So A is the hydrocarbon burned in the presence of oxygen that produced carbon dioxide and water. So the cobalt chloride paper will identify the water and water moisture the case which is placed in above. So this will turn its color from blue to pink. So the D is our correct answer here. The question number 30, the hydrocarbon C4H8 has the two structural isomers, but1-ene and but2-ene. So which statement is correct about that? So before going there, we shall see that there's the alkane formula is CnH2n plus 2. That's the homologous series formula for alkane. What about alkene formula is CnH2n? While the empirical formula is a simple whole number ratio of the atom present in a molecule. So for example, the molecular formula is a C4H8, while the simple whole number ratio will become C1 and H2, CH2. So that's the empirical formula. In the state number 1, the but2-ene has a structural formula. That's correct. And the same general formula. So they have the different general formula. Why? Because butane is an alkane and but2-ene is an alkene. So that's why the general formula is different. Now, but2-ene has the structural formula. That's a given there, so correct. And the same empirical formula. So their empirical formula is, that's the same. So you can see that the empirical formula of butene is also alkene, and ethene is also alkene. So they both belong to same homologous series. They have a same general formula, and they have same number of the carbon and hydrogen. So that's why overall their empirical formula will be same. So that's why the B is our correct option. What about the C is the wrong here? So the general formula of alkene and alkane is different. So second, and the D is also wrong because the molecule structure are wrong mentioned here. You can see that's supposed to be CH3, CH2, and then CH and CH2. So carbon should have a maximum bond 4, and a hydrogen should have a maximum bond 1. And in this way, we should fulfill the valency of a carbon and hydrogen. So wrongly, the molecule is mentioned here in the D. So that's why it is the correct statement is B here. The question number 31, which compound rapidly decolorizes aqueous bromine? So aqueous bromine is converting, for example, if we have the prop-1ene, so that will react with the bromine, and this will convert into addition reactions. And in this result, so the bromine will add with the prop-1ene, and that will produce 1,2-dichloropropane. So this will convert from alkene to alkane. So this will decolorize, the bromine will decolorize the propene. So that's why this is the D is our correct option here. What about if you see that the A is not giving response of addition reaction in the bromine. Next is B is a propanoic acid. It's also not giving this reaction. And alcohol, C is propanol, is not giving this reaction. So D is our correct option here. What are the product of the addition reaction of ethene with bromine and hydrogen? So you can see like the ethene that contain a double bond. So this will react with the bromine, and there will be addition reaction, and double bond will split into the single bond, and that the bromine will add with each carbon, and this will produce 1,2-dibromoethene. So in the same way, if we have the ethene, this will react with the hydrogen. This is addition reaction, and this will produce ethane. So the correct form, that will be our A is our correct form. You can see CH2Br and CH2Br. That's a correct formula. And in the same way, the hydrogen, that's addition of hydrogen produce alkane. So A is our correct option. Rest of all, B, it's giving alkene. So there's no change is being mentioned here in the B. So in alkene, so that's why this is wrong. What about in a C? There is only one substitution reaction is being mentioned here. So that's wrong. This is addition reaction of bromine. And in the D, the both options are wrong. So A is our correct option here. Ethanol is manufactured by fermentation and catalytic addition of steam to the ethene. So which row describes an advantage of both method? Now in this method, you can see from the sugar by fermentation, the ethanol need to be purified. This is disadvantage. While in B option, so that's from ethene and it's coming from petroleum. So these are non-renewable resources. So that's why this is raw material is coming from non-renewable resources. This is disadvantage. While in the C option, from the sugar by fermentations. So this process is a slow process by fermentation. So slow is a disadvantage, it's not advantage. So D option, renewable resources are used. That's correct. And ethanol produced that's a pure form. This also advantage. So D is our correct option here. Question number 34, methanoic acid and the propane 1-ol react to form of an ester linkage. So what is the structural formula for ester? So that's why you can see here, for example, if you have a methanoic acid, and this is going to react with propane 1-ol. So I wrote that hydroxyl group to the left side for your understanding. So you can see that the hydroxyl group is coming from the alcohol, and hydrogen is released by acid, methanoic acid, and that will release the one water molecule, and oxygen contain one side carboxyl group, other is the alkyl group, and this is our ester linkage. So correct form is A is our correct form here. So one side there is a carboxyl group is present, and oxygen is between the propane, and other side there is a carboxyl group. So that is A is our correct option. So B is the wrong. Why? Because this is ethyl methanoate. So that's the wrong the formula name is given there. What about the C is also ethyl ethanoate? It's supposed to be ethyl methanoate. So that's why that's wrong. And the D is our butanoic acid. That's also a wrong formula according to given equations. So the question number 35. What is the correct structure of PET? So that is the polythene terephthalate. So this polythene terephthalate, that's our polymer molecule, and we are making the different type of the plastic by that, or that's our organic molecule. So that's formed by terephthalic acid with ethylene glycol. So they combine by the esterification reactions. So the ester bond formed between these two subunits. So this ester bond means oxygen on one side is alkyl group, other side is a carboxyl group, and that is making the ester linkage. So we can see that what is the correct molecular structure of the PET. So you can see that A option is wrong. Why? Because there's a minor group is given there. So that is that's kind of the minor group is a wrong option here. Why? It's supposed to be ester linkage. While in the B, and oxygen on one side is carboxyl group, other is alkyl group here. So that's the B is the correct option, because it's showing the correct ester linkage. While in the C, once again, there's a minor group is there, and in the D option is wrong. Why? Because some ester linkage are missing in this molecule. So B is our correct statement here. Question number 36, alkane undergoes the substitution reactions in the presence of ultraviolet light. So which equation represent the substitution reactions of ethane? So how we define the substitution reaction is a part of the molecule is removed and it's replaced by another atom. So that is the substitution reactions. For example, there is the ethane that's react with the chlorine gas, and that's going to produce of ethene, and hydrochloric acid produced. So this is what happening. Dehydrogenation is taking place in A. So that's why the A option is wrong. So, and in the B option, you can say that's the ethane that's reacting with the chlorine. So if you are using ultraviolet light, and this will break the chlorine, the covalent bond, and in this way, the chlorine with a free radical, this will approach to the hydrogen and produce hydrochloric acid. Whatever the carbon with a free radical, this will take to the remaining chlorine, and this will produce the chloroethane. So in this way, the B is our correct option here. What about the C is the wrong option? Why? Because the ethane, we are adding only the chlorine here and removing the hydrogen. So in this way, there's the chlorination reaction is that taken place. So the chlorine is added here, and the hydrogen is only that's removed. So there is no substitutions reactions. So what about the D? So here we are having a hydrochloric acid with the ethane. So in that way, so in a ultraviolet light cannot break of a hydrochloric acid bond. So in that way, this reaction will not be possible in the presence of this condition of ultraviolet light. So B is our correct answer here. So here we can further understand this question. So methane react with the chlorine in a substitution reactions. So as we study, the substitution reaction is what? The addition of one atom by the replacement of another atom. So one is removing, other is being added. So that is called substitution reactions. So how many different product containing single carbon atom can be made during the reactions. So for example, if you're taking methane and in the result of the methane, if you're using ultraviolet light in the presence of chlorine gas, so this will break the covalent bond between the chlorine, and the chlorine will release with a free radical. This will have taken a hydrogen and produce hydrochloric acid. What about the carbon with a free radical? This will have taken a chlorine and produce the chloromethane in a first step. Now, this process will continue until the hydrogens are available on the surface of a carbon. So that way, once again, ultraviolet light, and this is further in the propagation reaction. So the chlorine will continuously releasing, and this will convert the chloromethane into dichloromethane. And in the same way, the dichloromethane, once again, under subjected by this substitution reaction, and that produce trichloromethane. And that's also called chloroform. So we are using this as an anesthesia. What about the ultraviolet reactions? Ultraviolet light will continuously breaking the chlorine, and in this way, this will continuously substitution reaction until it forms tetrachloromethane. So if you're counting how many different type of products are being produced, these are 4 different type of product. So that's why this is our C is our correct option here. Question number 38. So rock salt is a mixture of a salt and sand. So that's a mixture. And the method is used to separate the sand from the salt is listed here. So step number 1, we're going to crush the salt and add the water in that. So salt is soluble in water, but not in sand. So that way, that will get separate from the sand. And second step, pour the mixture and through the filter paper and hold in the funnel and evaporate the water. And then the salt will come in the water. And then after evaporation, we can get the crystal of salt. So which statement about the method is correct? So here, the filtrate is in a step 2 is a pure water. So in a step 2, the filtrate, which will come down, and the residue mean the sand will get separate on the surface of filter paper. So the filtrate, which will pass through the filter paper. So that's not a pure substance. Why? Because water contains salt, so it is not pure. It is in solution state. So the residue in a step 2 is a pure crystal of the salt. So the sand is a mixture of a different salt that is not a pure crystal. So that's why it's the wrong option. C, the solute is a salt in a low and small in amount that's dissolved into the water. So that's why it is working as a solute. Now, the solvent is a mixture of a salt and water. So the solvent, what we are having, it's only the water. It's not a mixture, because if it's a mixture of a salt and water, that will produce solution. It's not a solvent. So that way, the D is our wrong option. So C is our correct option here. The next question is about chromatography. 2 compounds M and N are dissolved into the water and separated by chromatography. So the results are written here. So we can see we need to find the retention factor here. So solvent is moving to the maximum 10 centimeter. So solvent front is on the 10 centimeter. So the baseline is from the baseline to the M is 2 centimeter, and M is away from the M. So what is the retention factor value for M? And which compound is most soluble in water? So first, we're going to find out the retention factor. So this is the movement of distance moved by the solute divided by the distance moved by the solvent. So solute move the 2 centimeter divided by the solvent move 10 centimeter. So that's equal to 0.2 is a correct answer. What about an N compound? It moved away or more longer as compared to the M. So that's why it has high solubility with the given solvent. So that's why the correct option is B here. The retention factor is 0.2 and the most soluble compound. And why? Because it moved longer distance. Question number 40, which acid is added to the salt X? A gas is produced which turn lime water milky. So here, if the lime water is turning milky, it means it's a carbon dioxide. So which option do not contain carbon dioxide? That will be excluded. For example, C is a wrong option. Why? Because if the lime water is turning milky, so that's releasing carbon dioxide, and this carbonate ions are not present in C, so that's why it's a wrong option. So next, when the sodium hydroxide is added to the salt X, so the gas is produced which turn lime pepper blue. So it means the gases has a basic nature, and this is converting the red litmus paper into blue in color. So that's why we can see that that's our ammonia. So remaining option D has no ammonia. That's working as a base. What about option A has no ammonia? So at anion, these are carbonate ion, it's supposed to be, which will produce carbon dioxide to turn the lime water milky, and cation, it's supposed to be ammonium ion, which turn the red litmus paper blue. So that's correct option is B here. So we have completed this paper, and hopefully it will be helpful for you. If you didn't understand any questions, so you can put your doubt in the form of question in the comment box. I'll try to answer your questions. Thank you. Thank you very much.